Hello, everybody. Welcome to another episode of What's Up with the Universe. I'm your host, Eli Hu, and I want to welcome everybody who's watching live. And if you're watching on the replay, I wanted to apologize for the little disclaimer that YouTube happened to put on here because of the topic of discussion today. Yes, you may scroll down and see there may be a Wikipedia link because I am talking about the antispherical club today. Yes, the flat earthers. The flat earthers, of course. Yes, I said the word. Flat earth. Earths. Many people believe that the earth is flat. I'm like, how could that actually possibly be? I'm like, come on. It's been said that since Christopher Columbus discovered the earth is round. Not true. It was actually the ancient Greeks that first made the discovery. While it's not immediately obvious that the earth is round from where you're actually standing, there's actual proof that the Earth's curvature is all around you. See what I did there? Over 2,000 years ago, the Greek philosopher Aristotle, he basically figured it all out. The fact that the Earth is round has been common knowledge ever since. In his book, On the Heavens, you can look it up, Aristotle, the book is called On the Heavens. He wrote, quote, "Again, our observations of the stars make it evident, not only that the earth is circular, but also that it is a circle of no great size. For quite a small change of position to south of or north causes a manifest alteration of the horizon." I mean, in other words, basically you see different sets of stars in the night sky depending on where you are. The sky over the northern hemisphere is not the same as the sky in the southern hemisphere. If the earth was flat, then at any given time, you would see all the same stars at the same time. And since that's not the case, we don't. I mean, another Greek, basically mathematician, Eratosthenes, he went further and managed to measure the Earth's circumference. He discovered that at noon in one Egyptian city, the sun was directly overhead. Of course, in a different city, the sun did not quite rise so high. He knew the distance between the two cities measured how high in the sky the sun rose to in each at the same time. Then he did some trigonometry. Did you know that the Bible even says that the earth is round? Yes, even Light Ministries. I don't promote them, but this is a quote. This is what they said right here. Job 26:10. He drew a circular horizon on the faces of the water. Isaiah 40:22, I apologize. It is he who sits above the circle of the earth. This is according to the Bible. You can tell for yourself that the earth is not flat. I mean, Earth from the ISS. People have claimed that these pictures are photoshopped with a fisheye lens. I mean, the curvature of the earth is visible in this 2014 photo, which ESA astronaut Samantha Cristoforetti snapped from the ISS. This is an actual picture, not with a fisheye lens. I mean, we have the moon in the night sky. I know, Mr. Miles. Okay, the moon. Humanity knows quite positively the moon is not a piece of cheese or some mischievous god in the night sky. This phenomenon that accompanies it is mostly cycles of lunar eclipses. They are well explained. I mean, it was quite a mystery to the ancient Greeks, though, and in their quest for knowledge, they came up with a few insightful observations that helped humanity figure out the shape of our planet. Aristotle, who made quite a lot of observations about the spherical nature of the earth, He noticed that during a lunar eclipse, when the Earth's orbit places directly between the sun and the moon, creating a shadow in the process, the shadow on the moon's surface is round. This shadow is the Earth, and it is a great clue about the spherical shape of the planet ourselves that we're on right now. A lunar eclipse. This is a sequential view of the lunar eclipse. So this occurred on April 15th, 2014. You can see the Earth's shadow crossing the face of the moon. And the shadow shape is curved because the Earth is spherical. Spherical means round. Since the Earth is rotating during a focal pendulum, you can experiment for a different proof if you are doubtful. The concentric oval shadow it produced in each and every lunar eclipse provides and proves that the Earth is not only round, but spherical. Absolutely, utterly, beyond a shadow of a doubt, not flat. Another example, ships on the horizon. If you've ever been next to the beach or something and just looked on the horizon, you see a very interesting phenomenon. Approaching ships do not just appear out of the horizon. They should have if the world was flat, but rather they seem to emerge from beyond the sea. I mean, you can say ships do not submerge, but rise up again as they approach a view. Of course, unless you watch Pirates of the Caribbean. But the reason ships appear as if they emerge from the waves is because not the world is flat, it is round. I mean, look at this example here. This is from Phil Plake's example. I love this example here. An ant on an orange. What would you see if you watched an ant crawling towards you over a curved surface? Imagine an ant walking along the surface of an orange into your field of view. If you look at the orange head on, you will see the ant's body slowly rising up from the horizon because of the curvature of the orange. If you would do that experiment with the ant approaching along a long road rather than a round object, the effect would change. The ant would slowly materialize into view, depending on how sharp your vision is, of course. Another way to prove the Earth is actually round is varying star constellations. This observation was originally made by Aristotle, of course, 84 through 22 BCE. He declared Earth was round by judging the different constellations one sees while moving away from the equator. On a round planet, stargazing on a round Earth, okay? After returning from a trip to Egypt, Aristotle noted, quote, there are stars in Egypt and Cyprus which are not seen in the northern regions. I mean, this phenomenon can only be explained if humans are viewing the stars from around the surface. Aristotle continued claiming that the sphere of the Earth is of no greater size, for otherwise the effect of so slight a change of place would not be quickly apparent. The further you go from the equator, the farther the known constellations go towards the horizon, to be replaced by different stars. This would not happen if the world was flat, as you can see right here with this diagram. You can also ride a plane. Hey, you ever taken a trip on a plane before? Look out the window. Planes can travel in a relatively straight line for a very long time and not fall off any edges. This can also circle the Earth without stopping. I mean, if you look out a window on a transatlantic flight, basically, you can see most of the time, see the curvature of the Earth on the horizon. The best view used to be on the Concorde, but there are some new Concorde type planes coming out. How about this classic one here? The polar gravity. Let me tell you a very interesting fact about mass. As soon as I take a drink, sorry. Okay. Mass. It attracts things to it. The force of attraction, gravity, between two objects depends on their mass and their distance between them. Simply said, gravity will pull towards the center of mass of the object. I mean, to find the mass, the center of the mass, you have to examine the object itself. The sphere center of mass. On a spherical surface, gravity will pull towards the center of the mass, straight down. Okay, consider a sphere. Since a sphere has a constant shape, no matter where you stand, you have the exact same amount of sphere under you. As you can see this diagram right here, imagine an ant walking around on a crystal ball. From an insect's point of view, the only direction indication of movement would be the fact that the ant is moving its feet. The shape of the sphere would not change at all. A sphere's center of mass is the center of the sphere, which means gravity will pull anything on the surface of the sphere straight down toward the center of the sphere. This will occur no matter where on the subject the object is located. Now, let's consider this on a flat plane. The center of mass is a flat plane, okay? In the center. So the force of gravity will pull anything on the surface toward the middle of the plane. That means if you stand on the edge of the plane, gravity will be pulling you sideways toward the plane's middle, not straight down like you usually experience when you stand on the Earth. A plane's center of mass. A plane's center of mass is in its middle, which means that gravity should pull objects toward the center of the plane. And I am quite positive that even for Australians, an apple falls downwards, not sideways. But of course, if you have your doubts, just drop something on the ground, you can prove for yourself. But okay, I've given you guys some explanations of some scientific explanations of why the Earth is actually round and not flat. But there's actually some simple ways you can prove it the Earth is round yourself. Simple things, simple tools, simple objects. For instance, take the toothpick experiment. Okay? I'm going to put this on full screen so you guys can actually see this. What you need to do is take 2 toothpicks into the side of an orange. Place the toothpicks about 1 inch or 2.5 centimeters away from each other. In this experiment, the orange will represent the Earth, and the toothpicks will represent objects located in 2 different countries on Earth. Turn off all the lights and shine the flashlight on the toothpicks. The flashlight will represent the sun in this experiment. Make sure the flashlight is the only light in the room. This experiment works best at night when there is no natural light around. Observe the shadow the toothpicks cause and the cast on the orange, okay? Notice how the shadow of each toothpick is different length and going in a different direction. Even if you move the flashlight around, the shadows will still be visible. Repeat this time, but not with toothpicks on our orange, but stick them on a flat surface, like a plate or a piece of cardboard will work. Keep the toothpicks the same distance apart as they were on the orange, 2.5 centimeters. In this version of the experiment, the flat surface will represent a flat Earth. Shine the flashlight on the toothpicks and notice how they both have the same shadow. No matter where you move the flashlight, the toothpick shadows will be nearly identical. Ask yourself, which set of shadows represent what we see on the Earth? It's the shadows that you saw on the orange, of course. After all, based on our observations here on Earth, we know that identical objects located in different parts of the world will have different shadows on the same time of day. I mean, that's because around us the Earth affects the shadows cast. If the Earth was flat, the identical objects would have the same shadow no matter where they were located in the world. Since that's not what we observe here on Earth, we know the Earth is not flat. Another way you can prove yourself that the Earth is not flat: go watch a sunset. Go to the beach, flat horizon, without any trees or buildings, basically best, like an open field or beach. Make sure the skies are clear so you can actually get a good sunset. What you're going to do is lay down on your back, turn your head toward the sun. Make sure you can still see the horizon when you're laying down. If you can't, find a better spot with a clear view. Wait for the sun to set, and then quickly stand up to see the sunset again. Yes, you want to stand up as soon as the sun sets beneath the horizon. When you do, notice how you can see the sun setting over the horizon again. Ask yourself, why a round Earth makes this possible? Well, think about it. If the Earth was flat, it wouldn't make a difference if you stood up quickly after the sunset. The sun would still be gone below the flat edge of the Earth. But since the world is round, standing up lets you see further over the Earth's curve. That's why you're able to see the sunset twice. I mean, if you were able to let the sun set again, then quickly get up to a high viewpoint, you could see the sunset for a third time. As the sun sets on the flat earthers tonight, I want to thank everybody for joining me today on this little trip here about how the Earth is round and not flat. I want to thank everybody here, and I want to remind everybody to don't forget to hit that, click that bell, click that like button. Don't forget to subscribe and ring that bell. So have a good night, everybody. Thank you. And sorry, Mr. Miles, no, I will not be doing the live eclipse streaming for tomorrow. That is too early for my time. It is over the north of the North Pole and very small parts of Europe tomorrow. But I will be tweeting about it. So have a good night, everybody.